identifiers, keywords, and data types. We will complete these three topics. Identifiers, keywords, and data types. These are very, very important in Java. So in second unit, we have the topics identifiers, keywords, data types, variables, literals or constants, operators, control structures, typecasting, and classes and objects. See, this topic we have covered in the last class, that is classes and objects. How do we define a class? After defining the class, how do we create objects for that class? In yesterday's class, we completed this topic, classes and objects. Now we will follow this order. First, we will discuss identifiers. After that, keywords, then data types. These are very, very important. So without understanding the basics, if you write the program, there is no meaning. Once you write the program, you should be able to explain each and every statement of that program in depth. Then now, first we will see identifiers. So in C language also we have identifiers, but there are few differences. Now I will explain the concept of identifiers. So first, with respect to identifiers, we will see what is an identifier and what are the rules for writing identifiers. So what is an identifier? Means it is a name given to a variable, method, array, pointer, class, interface, and package. So here the new terminology in Java is class, interface, and package. So the names of classes, interfaces, and packages also we will write using identifiers. So what is an identifier? Means simply we can remember it is a name like our names. So for methods, variables, classes, interfaces, and packages, we will give the names. So while giving the names to these, we should follow the rules for writing identifiers. If you understand the rules for writing identifiers, when you give the names for these classes or interfaces or packages, we will follow those rules only. Otherwise, you will get compiler errors. To avoid compiler errors, first we need to understand the rules for writing identifiers. So first we will see what is an identifier. Means it is a name given to a variable, method, class, interface, and package. And now what are the rules for writing identifiers? There are 6 rules. The first rule is it should be a combination of alphabets, means lowercase or uppercase, then digits 0 to 9, and the special characters are underscore and dollar. So identifier can be a combination of lowercase or uppercase alphabets, digits like 0 to 9, and the 2 special characters are underscore and dollar. Okay, in C language, only the special character underscore is allowed. Dollar is not allowed. But in Java language, we can use dollar also to write the identifiers. Next, the identifier should not start with a digit. Next, keywords cannot be used as identifiers. I will explain keywords. Next, what is the third rule is keywords cannot be used as identifiers. Next, identifiers are case sensitive, means lowercase alphabets are not equal to uppercase alphabets. Next, no restriction on the length of the identifier. In C language, restriction is there on the length of the identifier, but whereas in Java language, there is no restriction on the length of the identifier. We can take any number of characters. Next, last one is we can use predefined classes and predefined interfaces for identifier with one program. And now these are the 6 rules for writing identifiers. With these rules, we will give the already explained class definition is class name. So that class name is nothing but identifier. So how do we write the class names or interface names or package names? Is with respect to these rules. So that's why we have to remember the rules for identifiers. So once you understand these rules, we can easily give the names to variables, methods, classes, interfaces, and packages. Now I will explain one program. See, the last one is important. So we can use predefined classes and predefined interfaces for writing identifiers. Already explained, classes are of two types: user-defined classes, predefined classes. You know, some of the predefined classes are system, string, object, like that already explained. Predefined interfaces are runnable. So we can use predefined classes and predefined interfaces for identifiers. So in this program, I will explain that last sixth rule. We will see. So class name. So this class name is an identifier. Already we know the identifier rules. So already we know the naming conventions for writing class names. In the last class I explained. Naming convention for class name is here this class name consists of two words. If the class name consists of two words, then the first letter of the first word must be capital letter, and the first letter of the second word must also be capital letter. That's why here I is capital, D is capital. So we should follow the naming conventions for classes, interfaces, and packages. Because some developers followed the naming conventions for classes, interfaces, and packages, we should also follow the same naming conventions when you write your own classes, interfaces, and packages. Now, so here, class identifier demo. It is an identifier. It is the name of the class. This is an identifier. Next, see this main method syntax is public static void main string args. So inside the main method, now the first statement is int string is equal to 10. So here this int is a data type, string is a variable. Already explained, class name is an identifier, variable name is also an identifier. So here for identifier we are using predefined class name. Already as per sixth rule of identifiers, we can use predefined class names and predefined interface names for identifiers. So here int string is equal to 10. What is the meaning of this statement is, string is a variable which is of int data type and the value assigned to this variable is 10. So string is a variable. So data type, variable, and value. So this variable name is, here we have taken predefined class name. It is allowed. No compiler error. So after assigning like this, if you print the string value, because it is a variable now, which is assigned with 10. So if you print the value of just that string, you will get the output as 10. Means the predefined class names can be used as identifiers, means variable names. No problem in this. Next, when you take this statement, float runnable is equal to 20.7f. So this runnable is a variable which is of float data type. So this is called variable name. So variable name is an identifier. Class name is an identifier. Variable name is also an identifier. So here we have taken predefined interface name as identifier. It is correct only. So if you print the variable value that is runnable, you will get the answer is, output is 20.7. So here in this program, what we can understand is, we can use predefined class names and predefined interface names for identifiers. So here these two are variables, that is string and runnable are variables. Here we are using predefined class name and predefined interface name for variables, means for writing variable names. So this is the program to understand the sixth rule of identifier. Next, after knowing the rules for identifiers, we should be able to identify whether the name is valid identifier or invalid identifier. Because as per the rule, only we have to check whether the identifier is valid or not. We will see one by one. Some. Sum means here capital S, small lowercase um. Means it is a combination of lowercase alphabets and uppercase alphabets. Okay, so it is a valid identifier. Next, zero sum, invalid, because rule 2 fails. Rule 2 means identifier should not start with digit. That's why it is not a valid identifier. If you take this in place of variable name, you will get compiler error. Compiler will check the syntaxes. Next, sum hash details. It is also invalid. Only two special characters which are allowed for writing identifiers are underscore and dollar. But here we have used hash, means it is invalid. Only two special characters are allowed. They are underscore and dollar, remember. Next, sum space details. Space is also a special character which is not allowed for writing identifiers. That's why it is invalid. Next, dollar sum. Dollar is allowed and it can be placed in any position. So it is valid. Only digit should not be placed in the first position. Next, underscore sum valid. Sum 1, 2, 3 valid. Next, float. This is invalid. Why? Because float is a keyword. Keywords cannot be used as identifiers. So int, float, all these are keywords. Keywords I will explain later. Now try to understand float is a keyword and keywords cannot be used as identifiers. That's why it is invalid. So what is an identifier and what are the rules for writing identifiers? These are the 6 rules for writing identifiers. With this, identifiers concept is completed. Next we will go to the reserved words or keywords. This is also very, very important. So here in Java there are 32 reserved words. Not 32. In C language we have 32 keywords, but in Java language we have 53 reserved words. What is a reserved word? Means it is a predefined identifier and it is reserved for some specific purpose. Okay, that's why here again identifiers are of two types: user-defined identifiers and predefined identifiers. Predefined identifiers are nothing but either reserved words or we can say keywords. Means the meaning is defined for some specific purpose. User-defined identifiers means all the previous identifiers. Here we have written now. All these are user-defined identifiers. Means we are writing the identifiers as per the rules of identifiers. Like that, some developers also they have written some identifiers for some specific purpose. So here identifiers are of two types: user-defined identifiers and predefined identifiers. So predefined identifiers are nothing but reserved words or keywords. So in Java there are 53 reserved words. So here again reserved words are divided into two parts, that is keywords and reserved literals. Literal means constant. So what are the keywords and how many are there? So there are 50 keywords in Java, but there are 32 keywords in C language. And reserved literals means these are the constants. Again keywords are divided into two categories: used keywords and unused keywords. Out of 50, there are 48 used keywords and 2 unused keywords. What are the unused keywords? Are go to and const. Const means constant. So these are the unused keywords. We are not using these keywords in Java. That's why we have to remember only 48 keywords in Java language. We will see what are the 48 keywords. Next here reserved constants are true, false and null. These are constants: true, false and null. Boolean will take these two constants, that is either true or false. Null means reference variable we take. I will explain these later. Now we will see what are the 48 keywords. So this table shows the 48 keywords. So here if you remember as per the concept, then it is easy to write the 48 keywords on your own. So how to remember, I will explain with this table. So here the concept is here primitive data types or primitive data type here. Next flow control, next modifiers, Next, class, object, exception, and others. So if you remember these column headings, you can write on your own after understanding the concept. So first we will see. So primitive data types. So how many primitive data types in Java? There are only 8 primitive data types. Again in data types we will see these primitive data types. First try to understand the keywords. So the keywords which are related to primitive data types are 8. So they are byte, short, int, long, float, double, char and boolean. These are the only 8 primitive data types in Java. These are called keywords, all lowercase. Next, coming to this flow control. You know, flow control means control statements. Now they are if, else, do, while, for, switch, case, default, break, continue. All these keywords you know in C language. Same keywords. Next, modifiers. So in Java language we have access modifiers. They are private, protected, public, and static, abstract, final, strict FP, volatile, transient, synchronized, native. We will discuss these keywords later. All these we will discuss. Private, protected, public, static, abstract, final. When we go to the next concepts, we will discuss these keywords. Next, coming to the class concept. So with respect to class, we have these 6 keywords. They are class, interface, package. All these are keywords. Already explained. Class, class name, interface, interface name, package, package name. So these are keywords and the names are identifiers. So here with respect to class concept, we have class, interface and package. These are the keywords. Again with respect to these 3, we have 3 keywords. When we take class, in inheritance we have one keyword extends. When we take interface, we have the keyword implements. If you take package, the keyword corresponding to package is import. Already explained, the first statement in any Java program is import java.lang.star. That is the default statement which is provided by the compiler for every Java program. In that, java.lang is called the default package. No need to write that statement explicitly. Okay. So coming to class and extends. These 2 are important in inheritance. Okay. So these are the 6 keywords which are there with respect to this concept. Next, coming to the object concept, here we have 4 keywords. They are new. Already explained in the last class. How do we create an object is student S1 is equal to new student. New is an operator. Okay, it is an object related keyword. That's why new, instance of, this and super. These keywords I will explain later. But now remember, these are the 4 keywords which are related to object concept. Next, coming to exception. In Java we have one topic, exception handling. There we have 5 keywords. They are try, catch, finally, throw and throws. I will explain the importance of these 5 keywords when we go to exception handling. Next, others. Others means which are not related to any one of these concepts. They are enum, void and assert. You know, the return type of a function can be void if it is not returning anything. So these are the extra keywords which are not related to any of these topics. If you remember the column headings, accordingly if you write the keywords, then it is easy to remember these 48 keywords. So for primitive data types we have 8, for control statements we have 11, modifiers 11, class 6, objects 4, exception handling related keywords 5, others 3. So totally we have, if you add all these, we have 48 keywords. Try to practice this table. Okay, so the keyword concept is completed. Totally there are 48 keywords in Java language. In C language, 32 keywords. See, all the keywords which are there in the C language, they are available in Java also. But in addition to those keywords, there are extra keywords in Java language. Next, the third, till now we have completed identifiers and keywords. Now the next topic is data types, which is very, very important in Java language. Now coming to data types are divided into two parts in Java language, that is primitive data types and non-primitive data types. So this primitive data types concept is there in C language, but in C language there is no concept of classes and objects. That's why in C language we don't have the concept of non-primitive data types, because classes and interfaces are not there in C language. That's why this is the extra part we have to remember with respect to data types in Java language. Okay, so in Java language data types are divided into two categories. They are primitive data types and non-primitive data types. So first we will see what are the primitive data types, then we will see non-primitive data types. So this concept is very, very important. This is heart of Java language, because in each and every program we will use primitive data types and non-primitive data types. That's why to understand each and every statement in depth, first we need to understand the basics. Now coming to primitive data types, already explained here, there are only 8 primitive data types in Java language. What are the 8 primitive data types? Byte, short, int, long, float, double, char and boolean. So these are the only 8 primitive data types in Java language. Okay. Now we will discuss the 8 primitive data types. Now these 8 primitive data types are further divided into 3 categories. They are numerical, character and boolean. So coming to numerical, again integers and floating point numbers. Coming to integers, actually we have to write these 4 in the same level. They are byte, first byte, then int, short, then first write byte, then short, then write int, then long. So coming with respect to integers, we have 4 data types. They are byte, short, int and long. Next, coming to floating point, here we should write float and double. So integers are 4, they are byte, short, int, long, and floating point numbers are 2, they are float and double. Up to this, numerical data types are 6. Next, but there are 8 primitive data types now. Character is another data type, char. Next, boolean is another data type. So char, boolean are also primitive data types. So here there are only 8 primitive data types. You should remember the order is byte, short, int, long. These are integer data types. These are numerical data types or integers. And float and double are floating point numbers, numerical only. Then next data type is char for character type. Next boolean for boolean data type. So these are the 8 primitive data types which are available in Java language. Next, coming to the non-primitive data types, there are only 2 types. They are classes and interfaces. Already explained class. So class is a non-primitive data type. Like that, interface is also a non-primitive data type. Why these are called non-primitive data types, I will explain later. Now coming to the primitive data types, here we have 4 integer data types. They are byte, short, int and long. So here, out of these 4 data types, what is the default data type and what is the default value? These 2 are important with respect to the integers data type. So here we have 4 integers data types now. They are byte, short, int, long. Out of these 4, the default data type is int. Next, what is the default value is 0. So for integers data type, the default value is 0 and default data type is int, because here we have 4 data types now. So here int is the default data type out of these 4 data types and the default value is 0. Now you try to remember, after that we will write the programs. Next, coming to the floating point data types, there are 2 floating point data types. They are float and double. Oh, so here the default data type is double. Okay, of these two float and double data types, the default data type is double and the default value for floating point numbers is 0.0. I will explain these in depth later. Now remember only for integers the default data type is int and the default value is 0, and for floating point numbers the default data type is double and the default value is 0.0. Next, coming to char, here it is only one data type, no, and therefore the default value for char is \u 4 zeros, that is blank space. Okay, \u 4 zeros is nothing but this is hexadecimal notation. The integer notation for that is 0. You know the ASCII value for blank space is 0. Okay, so the default value for char data type is, or character data type is 0. Next, here Boolean takes only two values, either true or false. The default value for Boolean data type is false. So you have to remember default data types and default values for numerical, character and Boolean data types. Now I will explain the data types in depth. So data types are of two categories, primitive data types and non-primitive data types. So there are 8 primitive data types. We will see the 8 primitive data types in depth. Now what is the first primitive data type? Byte. It is an integer data type. Now coming to byte, what we should know is what is the size of the byte data type. So size of the byte data type is 1 byte. You know 1 byte is equal to 8 bits. Next, what is the range for byte data type? So range for general formula is this one, that is size or range, both are same. The formula for finding the size of any data type is minus 2 power n minus 1 to 2 power n minus 1 minus 1, where n is the number of bits for that data type. So here already explained, byte size is 1 byte, that is 8 bits. So n is 8. So if you substitute n is equal to 8 in this formula, you will get the range for that data type, that is minus 2 power 7 to 2 power 7 minus 1, which is minus 128 to plus 127. So the range for byte data type is minus 128 to plus 127. It will take the value within this range only for byte data type, starting from minus 128 to 0, that is negative side, and from 0 to 127, that is positive side. Next, what is the minimum value? That is minus 128. Max value is plus 127. So byte will take, we can take closed interval minus 128 to 127. Closed interval means endpoints are also included. Okay. So this is regarding byte. So you can remember this order. Byte will take how many bytes? 1 byte. So the order is byte, short, int, long. These are the integer data type. That is byte takes 1 byte. Next is 2, short, int 4, long 8. So if you remember 1, 2, 4, 8 and this order, it is enough for knowing the sizes of the data types. Next, if you take float and double, float will take 4 bytes and double will take 8 bytes. So remember the order: byte, short, int, long, then float to double, then char, boolean. So these are the 8. So 1, 2, 4, 8 for integers data type and 4 and 8 for floating point data type. Char will take 2 bytes. So remember these values. Now we will complete byte. The first data type is byte, because it is taking only 1 byte, no memory. That's why it is the first one. Next, how do we declare byte type variable? So here we can see byte B. Means B is a variable which is an identifier and which is declared with byte data type. So B is a variable and which is of byte data type. Next, here suppose here we have not assigned the value, no. So unless you assign the value for this byte variable. So what is the default value of integer data type is 0. That's why the memory is allocated for B with 1 byte and the value 0 is stored in that B variable. Why? Because the default value for any integer data type, whether it is byte, short, int, long, is 0. That's why unless you assign the value for this variable, the default value is 0 is stored in the variable B and memory is 8 bits. Already you know in C language, if you won't initialize the variable, garbage value is stored in that variable. But here in Java language, garbage values are not stored. Unless you assign the value for that variable, it will check the data type. If it is integer data type, then the default value which is 0, that is assigned to this variable B. You have to remember this point. Next here byte B is equal to 10. Here we have not initialized, that's why default value 0 is stored in this variable. But here we have assigned the value 10. That's why here memory is allocated for this variable with 1 byte, that is 8 bits, and 10 is stored in this variable B. Now here we have to understand one more point. So byte B is equal to 10, here byte B is equal to minus 10. How internally how the value 10 is stored in this variable B is, here the procedure is, here we can understand one more point. Due to this assignment operator, first right hand side is evaluated, after that is assigned to the left hand side variable, you remember. But what we think is, first byte B is there now. Follow this concept carefully. Byte B means we will think that 1 byte is means 8 bits of memory is allocated for this variable B. In that 10 is stored. Actually we will think like that, but it is not the correct way of storing that value 10. So what is the correct way is, you know the assignment operator now. Assignment operator means first assignment operator follows right to left associativity. You know precedence and associativity of operators. So this assignment operator follows right to left associativity, means first 10, this right hand side has to be evaluated, after that is assigned to this left hand side due to this assignment operator property. So first evaluate the right hand side, after that assign that value to the left hand side. So first we know only right hand side. When we see the right hand side, so we can't say no whether it is declared with byte variable or short variable, byte data type or short data type. That's why here default data type comes into picture. Already I explained the default data type for any integer, whether it is byte, short, int, long, it is int. Okay, first only see the right hand side. The compiler will see only right hand side. It doesn't know about the left hand side. Okay, first it has to evaluate right hand side. If we see the right hand side part, we don't know which data type it is. That's why default data type comes into picture, and we know the default data type for all the 4 integer data types is int. Now that's why first it will take the right hand side and it will assume that it is int data type. You know int will take 4 bytes of memory. That's why initially 4 bytes means 32 bits of memory is allocated, and this 10, the binary form of this 10 is stored in that 32 bits of memory. What is the binary equivalent of 10? You know 1010. You know how to write. This is 2 power 0, 2 power 1, 2 square, 2 cube. Means 8 plus 2 is 10. So first convert this integer into binary form. After that, the binary equivalent of 10 is stored in the 32 bits of memory. So all these are zeros, and take the leftmost bit, that is for sign. 0 is for positive and 1 is for negative, because this integer, all the integer data, all the numerical data types are unsigned or signed. Signed means we can take positive values as well as negative values. That's why when we take byte b is equal to 10, or when we take byte b is equal to minus 10, so it will keep the leftmost bit for sign. It will put 0 for positive values, it will put 1 for negative values. That is the importance of leftmost, that is leftmost bit. Okay, it is only for sign. So first initially, because the default data type of this 10 is int, that's why 32 bits of memory is allocated. In that 32 bits, the binary equivalent of this 10 is stored, and in the leftmost bit, here it is positive, that's why 0 is stored. This is the right hand side evaluation. So after evaluating this right hand side part, then it will see the left hand side part, because this right hand side is assigned to this left hand side variable, because this is assignment operator. Okay, now what is there in the left hand side for this assignment operator? Byte b. Now byte b means, we know byte takes one byte, that is 8 bits. That's why now 8 bits of memory is allocated, because byte b, and the name of this memory is b, and this is the right hand side part. Now this is assigned to this one. So when this is assigned to this, it can easily hold the value 10, because the range for the byte is minus 128 to plus 127. It is within the range of byte only 10. That's why the value which is stored in 32 bits of memory can easily be assigned to this byte variable b. That's why after assigning this into this is the final memory. So what is the final memory? This is 1 byte, 8 bits. In these 8 bits, the binary equivalent of 10 is stored, that is 10, 1010. Remaining are added with zeros, and the leftmost bit is for sign. That's why 0 is for positive, plus 10. Okay, final answer is this one. Don't write final answer directly like this. When somebody asks, explain this statement, byte b is equal to 10 means, first we should explain right hand side. After that, right hand side is assigned to the left hand side. Okay, this is very, very important. Once you understand this concept, the same way we can apply for any statement in numerical data types. Next, byte b is equal to minus 10, same concept. First, right hand side is evaluated. Here only difference is the leftmost bit is for sign, that is 1. See, here we can understand, even though byte is taking 8 bits, but we are using only 7 bits for storing the number 10, because we are using this bit, leftmost bit, for sign. No? That's why even though we are having 8 bits, but we can use only 7 bits for storing the actual number. Okay, this is also important. Only 7 bits are used for storing the actual number. Now, once you understand remaining, you can study on your own. So byte b is equal to 129. First, it will take right hand side only. Right hand side means it is the default data type is int. First, it will take 32 bits of memory. In 32 bits, the value can easily be stored. But after that, that 32 bits of memory means the value 122 is assigned to this. No? So while assigning this value into this, there is a problem. Memory is not sufficient. That's why here it will give you compile time error. Don't say it is not within the range of byte, that's why compiler error. Actually, how to explain this statement is, first memory is this object 129 is the default data type for any integer value is int. That's why 32 bits of memory is allocated. It is within the range of int only. That's why 129 is stored in the 32 bits of memory. Right hand side is no problem. It can easily we can easily put this 129 number in 32 bits of memory. But after that, because of this assignment operator, when we are assigning this value into this byte variable, here it will take only 1 byte. But here this is 129. So this is out of the range of byte. That's why this number cannot be stored in 8 bits of memory. Like that you should be able to explain. That's why compiler error you will get when you write like this statement. Next, byte b is equal to 10.5. After that, write system.out.println b. Here also byte b is equal to 129. After that, system.out.println b means we are trying to print this b value. At that time, you will get compiler error. Next, byte b is equal to 10.5. It is a double, no? Means floating point number, no? It cannot be stored in this integer data type. That's why cannot a compiler error. When you print system.out.println b, in that statement you will get compiler error. Why? Because what is the compiler error means? Possible loss of precision, found double, required byte. So we need byte value, but we are giving double value. Like that you will get the compiler error. Next, byte b is equal to a. Same. Compiler error, incompatible data types. Here you can understand the difference between these two errors. Here 10.5 is numerical data type and byte is also numerical data type. That's why here it will give you possible loss of precision and found and required. But here which type of compile time error we will get is, here both are incompatible types. Because it is numerical data type, it is character data type. That's why the error you will get incompatible data type. When you write the program and if you execute this, you will get the compile time error like this. That is saying that incompatible data types. Because this is numerical data type, this is character data type. That's why both are not compatible. That's why incompatible data type found. What it found is char, what required is byte. Next, like that you should know some errors also. Next. Okay, next coming to the next data type is short. Write the same way. Short take how many bytes? 2 bytes. 2 bytes means 16 bits. 16 bits means if you apply the formula, you will get minus 32,768 to plus 32,767. This is the range for int in case of C language. But in Java language, this is the range for short. This we can remember. Next, what is the minimum value, maximum value? Like that you can read. Already explained these, no? So how do we declare the variable with the short data type, short s? So here, if you print a system.out.println s, means the default value is stored. What is the default value for any integer data type, whether it is byte, short, int, long, is 0. That's why when you print here system.out.println s, you will get 0. Next, these you can easily understand. Next, same. If you write out of the range, again here also follow the same concept. First it will evaluate right hand side. That's why the default data type for any integer data type is int. That's why here it will take 32 bits first, and this value can easily be stored in the 32 bits. After that, while assigning this value into short will take only 2 bytes of memory, and the range is minus 32,768 to 32,767. But while copying this value into 2 bytes of memory, there is a problem. That's why compiler error. Next, short s is equal to incompatible types. Next, this is also possible loss of precision. Same concept. Next, coming to int also same. You can easily understand this one. Next, int range is size is 4 bytes 32 bits. Next, these also you can easily understand like that. Now coming to long, this is the fourth data type. The integer data types are 4. They are byte, short, int, long. Now coming to the long data type, size is 8 bytes. 8 bytes means 64 bits. Range is, we can write formula only. All this we know. But here with respect to long, one important point is there. I will explain here. Now here also you can easily understand the default data type concept. Why default data type is required and how to apply the default data type. Here also we can easily understand. Now long L. Here the value, here it is not initialized with value. No? If you print the value of L, you will get 0 only. Because the default value for any integer data type is 0. That's why here you will get 0. Next, long L is equal to 100. If you print the L value, you will get 100 only. Next, but how this statement is evaluated is here also same. Understand assignment operator. Assignment operator means always first right hand side will be evaluated. After that only it will be assigned to the left hand side. So here it will see first compiler 100. 100 means we can understand that it is an integer value. So the default data type for any integer value is int. That's why here first 32 bits of memory is allocated. In that 100 value, binary equivalent of 100 is stored, no problem, because it is within the range of int only. That's why 100 is stored in 32 bits of memory. After that, this value is assigned, 32 bits of memory is assigned to this long. Long means 8 bytes, no 64 bits. So this value can easily be copied into this variable, correct only. There is no problem. Next, coming to this statement, again this is some value, no? Again same concept. First take the right hand side value. It is an integer because there is no decimal point. It is an integer means first the default data type for any integer is int only. So 4 bytes of memory is allocated. So in that 4 bytes of memory means in that 32 bits the value has to be stored. But while storing the binary equivalent of this value into 32 bits of memory, there is a problem. This is outside the range of int. So int will take only 4 bytes, that is 32 bits. But while storing this value in that 32 bits of memory, this number cannot be stored in 32 bits. Why? Because it is outside the range of int. That's why here there is a problem. Now here you can understand the default data type concept. Suppose if you take left hand side, first if you evaluate left hand side, what is the meaning of left hand side? Long means you know it is taking 8 bytes. Suppose if it evaluates left hand side first 8 bytes of memory is allocated for this variable L, and in that this value can easily be stored. No, then what is the problem? Suppose if it evaluates left hand side first, then right hand side means the statement is correct only. There is no problem in the statement. But it is not like that. Due to the property of assignment operator, always assignment operator follows right to left associativity. Right to left associativity means first right hand side has to be evaluated. After that is assigned to the left hand side. If you follow this, then only you can understand this one. Otherwise, what is the problem? There is no problem if you take first left hand side, then right hand side. Left hand side means 64 bits. In 64 bits, this value can easily be stored. What is there? That's why always follow the assignment operator property. Then only you can understand all these concepts. So that's why first right hand side, then left hand side. Right hand side also it is an integer. That's why the default data type is int. Means only 32 bits of memory is allocated for right hand side, but this value cannot be stored in 32 bits of memory. That's why here it is a problem, even though log is taking 8 bytes of memory. And then what is the, but here it is within the range of int only. That's why first 32 bits of memory is allocated and the binary equivalent of 100 is stored in that 32 bits. After that, it is copied to this variable L, which is taking 8 bytes. Means it is 100% correct. So here, but it is error, even though it is taking 8 bytes. Why it is error means first it is evaluating right hand side. That's why it is an error. So how to overcome this error is by taking suffix L. Okay. So here you can understand 2 points. When you take the long data type, if the right hand side value is within the range of int, then the suffix L is not required. Next, if it is not within the range of int, then the suffix L is required to use these 8 bytes. Otherwise, if you write like this, we are not using 8 bytes. No, we are using only 4 bytes, and we are saying this value cannot be fitted into the 4 bytes of memory. That's why error. How to overcome this error is by taking the suffix L. So suffix L is always not required. So this is the correct statement. If you write like this, you can use all the 8 bytes of memory which is allocated for long. If you write like this, we are not using this 8 bytes. Only we are using 4 bytes because it is evaluating first right hand side and the default data type is int. Next. So here L is optional. L is when L is required is, you note on this, if the value is, means if the right hand side value is within the range of, this is not L, it is int. So if the right hand side value is within the range of int, then no need to take the suffix. Here this we can take either small l or capital L. Next, if the value is outside the range of int, it is also int, not L. So if the value is outside the range of int, then we need to suffix the value with either small l or capital L. So regarding long, we have to remember these 2 points. Next, coming to float, you know float is taking 4 bytes. Float and double 4 and 8. So if you take byte, short, int, long, you need to remember the order is 1, 2, 4, 8. Coming to the floating point data type, float and double, remember the order is 4 and 8. So 4 bytes, it is also easy. The range is minus 3.4e, 3.82, this one. Minimum value, maximum value. Here it is single precision. Single precision means 5 to 6 decimals of decimals after point, and it is less accuracy. Next, coming to double also, compare these two and study. Size is 8 bytes and range is this one. It is double precision. Double precision means after decimal we can take more points. That is 14 to 15 decimals of precision, more accuracy. But only the important point here we need to remember is when how to declare float and what is the default data type for floating point numbers is double. And the default value for floating point data types is 0. So these 2 points we need to remember in case of floating point data types. They are what is the default data type for floating point data types and what is the default value for floating point data type. When default value comes into picture is, if you won't assign the variable with any value while declaring the variable, then the default value is stored in that variable. That's the second is when default data types when default data type comes into picture is when you use assignment operator. When we use assignment operator, always right hand side is evaluated first. After that, left hand side. When you evaluate the right hand side, this part, then here there is no data type which is there with this value. No, only left hand side we can observe the data type, but right hand side only we observe the value. We don't know the data type. How do we know the data type for the right hand side value is based on the default data type. So here in assignment operator concept only, you will get the default data type concept. That's why what is the default data type for integer data types is int. And what is the default data type for floating point data types is double. So this is regarding default data type. And default value for integers is 0. And the default value for floating point numbers is 0.0. When we use the default value concept is when you declare the variable without assigning a value for that variable, then the compiler will automatically assign default value for that variable. Here there is no concept of garbage value. In C language, unless you assign the variable with any value, garbage value will be stored. Garbage value means any value. It will change from execution to execution. But here, default value, if you execute the same program 100 times also, always it will print the default value only. That's why default data type and default value, these two are very, very important with respect to data types. So the default data type for integers is int, and the default value for integer data type is 0. Default value is 0, default data type is int. Because in integers we have 4 data types. They are byte, short, int and long. Okay. So here we have 4 data types. That's why we should remember what is the default data type, that is int. And what is the default value for all these 4 is 0. And coming to floating point numbers, the default data type is double and the default value is 0.0. Next, here with respect to float, we need to remember one important point. So always whenever you assign a value for this floating point variable, we need to take the suffix f. So if you write like this, you will get compiler error. What is the correct statement for this is float f1 is equal to 9.3 f. F is compulsory here. In case of float data type, f is must, suffix f is must. But in case of long data type, already explained, sub L is optional. When it is optional and when it is compulsory is, if the value is within the range of int, then it is optional. If the value is outside the range of int, then it is must. Okay, here within long data type, sometimes L is required, sometimes L is not required. But regarding this float data type, F is always must. Why I will explain here. Suppose if you won't take F, what will happen is float F1 is equal to 9.3. Again see the assignment operator. Means only concentrate on the right hand side. So right hand side the value is 9.3. What is 9.3? Already explained. 9.3, you know, it is a floating point data type value. Floating point data type, what is the default data type for floating point data types is double. There are two types of float and double. Now double is the default data type for floating point data types. That's why right hand side data type, it will take it as double. Double means it will take double precision. Memory is with double precision, that is 14 to 15 decimals it will take for this 9.3. To store 9 in the first part, after decimal it will take 14 to 15 decimal points it will take. This is right hand side is correct only. It can easily evaluate right hand side, no problem in this. But after that, this is assignment operator. No? Here float will take 4 bytes. Here double will take 8 bytes. So while copying or while assigning this value into 4 bytes of memory, so how many, what is the precision? 5 to 6 decimals. Here float is having 5 to 6 decimals, but here double is having 14 to 15 decimals. So while copying that double value into float value, it cannot copy. That's why here you will get error. That's why if I take 9.3f, in place of 9.3, if I take 9.3f, what will happen is the compiler will understand that this value 9.3f is for floating point data type. That's why using this 9.3f, compiler will assign only 4 bytes with 5 to 6 decimals of precision. And in that the 9.3 value is stored. After that, while assigning this 9.3f into float, there is no problem. This is also 4 bytes of memory. This is also 4 bytes of memory with the same precision. That's why we need, it is must for floating point numbers. When you declare a floating point value with float data type, suffix f is must. Otherwise error, compiler error, syntax error. So float f1 is equal to 9.3, f we should mention. That is the reason why. Next, when you take double d is equal to 9.3. Anyway, it is 9.3 is the default data type for 9.3 is double only, no? That's why 8 bytes of memory is allocated and 14 to 15 decimals. And while copying the same with 8 bytes and with the same precision, no problem. Next, if you take double d1 is equal to 9.3d, means we are saying to the compiler that d means again same. So this both are giving the same meaning. That's why for double, the suffix d is optional. This d can be small d or capital D. So what are the final points are? With respect to double, the suffix d is optional. Okay, it is not must. Okay, always it is optional. If you write 9.3 or 9.3d, you will get the same answer. But in case of floating point, if you write only 9.3, you will get error. So you need to explain why we are getting error using this double concept. Next, so for floating it is must, but for long it is not always compulsory. If the value is not only within the range of int, it is not must. The suffix L is not must. But if the value is outside the range of int, then suffix L is must. So with respect to this numerical data types, that is integer data types and floating point data types, these two concepts are completed. Next class we will see character and Boolean data types. After that we will go to the variables concepts. First, if you understand basics, then the Java programming is very easy language. That's why you try to focus on the concepts.